Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0328, indicates a high voltage issue in the knock sensor circuit of the Honda CR-V models from 2011 to 2016. The knock sensor is a crucial component in modern vehicles, responsible for detecting engine knocking or pinging, which is a sign of unwanted combustion. This malfunctions can lead to engine damage if not addressed. Locations of this sensor typically are located on the engine block. The Powertrain Control Module, PCM, uses the signals from this sensor to adjust timing to prevent knocking. The high voltage signal indicates an anomaly, pointing towards potential wiring issues or a faulty sensor. The knock sensor plays a vital role in ensuring engine efficiency by detecting abnormal combustion. If it senses knocking, it sends a signal to the PCM to adjust the ignition timing to facilitate smooth operation. Typically, the knock sensor is located on the engine block, a strategic position that allows it to adequately sense vibrations caused by knocking. The sensor connects to the PCM via a 2-pin connector, commonly referred to as the 2P connector. If the PCM is receiving high voltage readings from the knock sensor circuit, it could be indicating an internal issue within the sensor or potential wiring problems leading to it. Therefore, any repairs should focus on these critical components. The potential causes of DTC P0328 include a faulty knock sensor that may be providing incorrect voltage readings due to internal failure. Poor wiring integrity, such as frayed wires or bad connections, can cause high voltage signals to be sent to the PCM. It is also possible that terminal connections at the knock sensor or the PCM are loose or corroded, leading to inconsistent electrical signals. Each potential cause should be systematically examined during diagnostics, starting with visual inspections of the wiring and connections, followed by component testing to identify the source of the malfunction. Symptoms associated with DTC P0328 often include noticeable engine knocking or pinging sounds, especially when the engine is under load or during acceleration. This can lead to poor engine performance, as the vehicle may experience hesitations or a reduced ability to accelerate. Additionally, the check engine light will illuminate, alerting the driver of a problem within the engine management system. If these symptoms are present, it's crucial to address them promptly to avoid potential engine damage or decreased fuel efficiency. Begin the troubleshooting process for DTC P0328 by turning the ignition switch to the on position, ensuring the engine is off. Next, clear the DTC using the Honda Diagnostic System, HDS, which allows the technician to reset the engine codes and assess the current status. After clearing the DTC, switch the ignition off to the lock position and then return the ignition to on. It's essential to check for any pending or confirmed DTCs using the HDS again in this state. If DTC P0328 is still present, it confirms that the issue needs to be addressed. If it does not appear, there may be an intermittent issue requiring further investigation of connections or terminals. For the second troubleshooting step, start by turning the ignition switch to the lock position to ensure safety while working on electrical connections. Disconnect the knock sensor 2P connector to isolate the sensor from the electrical circuit. Once disconnected, turn the ignition switch back to the on position. Using a multimeter, measure the voltage between the two test points on the knock sensor connector. Specifically, measure from the knock sensor 2P connector's terminal 1, known as the black wire, BLK, to terminal 2, the white wire, weight. You should expect to see approximately 5.0 volts. If this voltage is present, it indicates that the wiring to the sensor is intact and that the next step would involve replacing the knock sensor itself. Continuing with the troubleshooting process, you will need to measure the voltage at the knock sensor connector again by conducting tests under specific conditions. Ensure the ignition is turned on while the knock sensor 2P connector remains disconnected. This time, measure the voltage between the white wire of the knock sensor connector and body ground. Again, you are looking for approximately 5.0 volts. If the reading is satisfactory, it suggests that the signal line to the sensor is functioning as it should. If the voltage is not present, it suggests a potential fault in the KS line or ground issues in the KS-GND line, leading you to the next step in the repair process. In this step, you will be performing an open wire check on the KS-GND line to determine if there are any faults present. Start by turning the ignition switch to the lock position for safety before jumping the SCS line using the HDS. This shortens the circuit to diagnose issues accurately. Next, disconnect the PCM connector C, which consists of 49 pins. You will then use a jumper wire to connect terminal A from the knock sensor 2P connector, black wire, to a body ground. At this point, you will check for continuity between the connector of the PCM and body ground to confirm the integrity of the KS-GND line. Successful continuity would indicate that this wire is functioning correctly, while a lack of continuity necessitates repairs to the KS-GND wiring. As you approach the final steps of the troubleshooting process, you will conduct a continuity check on the KS line similar to the previous step. Again, power down the system by turning the ignition switch to lock, and then proceed to short the SCS line with the HDS. Afterward, disconnect the PCM connector C. Utilize a jumper wire to connect the white wire from the knock sensor 2P connector to a body ground. Measure continuity between the PCM connector and body ground to ensure that the KS line is intact. If continuity is recorded, the KS circuit is verified as functional. If not, it denotes a break in the KS wire that would require immediate attention and repair to restore proper function. After completing all necessary repairs indicated by the troubleshooting steps, it's crucial to perform a final repair verification to confirm that the issues are resolved. Start by reconnecting all connectors, ensuring a snug fit without corrosion or damage. Then, turn the ignition switch to on to power the system. Reset the powertrain control module, PCM, using the HDS, which will also clear old data and prepare the system for a fresh evaluation. Finally, check for any pending or confirmed DTCs using the HDS. If DTC P0328 still appears, further diagnosis may be required depending on the current state of the vehicle's electrical systems. To prevent issues related to DTC P0328 from occurring in the future, implementing a routine maintenance schedule is essential. Regularly inspect the electrical connections related to the knock sensor and PCM for signs of wear, corrosion, or loose fittings. Any detected issues should be addressed immediately to maintain effective sensor communication. Additionally, keeping the PCM software up to date is crucial as manufacturers release updates that enhance performance and fix known bugs. Scheduling periodic checks of sensors and all connected wiring can help catch potential issues before they develop into significant problems, safeguarding the engine's performance and longevity. In conclusion, resolving DTC P0328 is fundamental to ensuring the optimal performance of the Honda CR-V from 2011 to 2016. The knock sensor plays an integral role in engine management by preventing knocking and enhancing efficiency. Thoroughly check all wiring and connections during troubleshooting, as integrity and proper connections impact the sensor's functionality. Always address DTCs promptly. Any malfunction can lead to severe engine damage or reduced vehicle performance. By undertaking appropriate preventive maintenance and understanding the integral components in the knock sensor system, you can avoid recurrence and extend the life of your vehicle. Please like and subscribe to the channel. See you next time.